All right, so let's examine how close data is to linear models. That's what we did today. And we did that by evaluating what we call residuals. Okay, so you'll know you're successful if you can plot. We didn't practice the plotting, but if you can plot and calculate residuals for a data set and use the information to judge whether a linear model is a good fit. So, do we all know how to put it into Desmos? How to plot a residual plot in Desmos? Okay, so then let's see. So I'm just going to give a random set of data, like you will usually be given. So let's do for x's 1, 2, 3, 4. Okay. Let's see, what do I want to measure? Let's do something like this. Okay, so I just put some random data. Anyway, you can see it plotted up here, but you cannot have a residual plot without a linear model to go off of, because residuals are your actual minus your estimated. So I have some data. What do I need to type in here so that I can get a residual plot? Now, let's see if I can remember where the squiggle is on here. There it is. Okay, y1 squiggle mx 1 plus, and then I put here it is. All right, so same thing you would for a linear model. Type that in. How do I make the residual plot appear? Okay, right here. If your question says something about residuals, you might benefit from having the plot here. One, it'll calculate the residuals for you. So like if you click on each individual data point, this is my X, this is my residual. If I go to my table, and of course I actually would need to figure out what my linear model is saying so that I can calculate actual minus estimated, but they're saying my residual is 1 for that data point. Is 1 pretty close to 0? Yes, so then look at some other residual values. For when my data point is 2, my residual is negative 1.5. When my data point is 3, my residual is 0. When my data point is 4, my residual is 0.5. So out of these 4 dots, and it's these 4 x's, also notice it gives you your residuals in the table too. Which residual input is the best? When x is 3, because my residual is telling me that it's 0, meaning my actual matches my estimate. Would you say, based on how this looks, that this is a good line of fit? Okay, you think no? Anyone think yes? You just need to be able to justify it either way. It'll always give you for the best line of fit. So when you put your data in, it'll always give you the best line of fit. It touches almost all the dots, or it's at least really close to all the dots. Wouldn't you say that this is pretty close to the x-axis? These dots. And when you say that all these values are pretty close to 0, so it is a good fit for the data, this linear model. It'll always give you the best one. But if you see that they're way off, so say I change this data point to, I don't know, let's see, a number way different. Let's make it like 100. Oops, no, I don't want to make that 100. I want to make the other one. Oh, sorry, sorry. I'm looking for 2 students. No, that's today. Sheffy and Illusion. Sorry if I said it wrong. They need to. Take your things with you. Okay, yeah, just take all your stuff with you. All right, but look at how this changed. So I changed that data point of, I forget what it was, 19 to 100. First of all, do I even see my residual dots around as much? Do I see all 4 of them? No, because one of my residuals, 24.8, I can't see that far on my y-axis unless I zoom out. Also look at my linear fit compared to the green dots. Now I have a green dot way up here. All right, so you can see, you know, in relation to how well our data is, if this was something, and I don't know what we could be comparing, but grades on a math test. All right, out of 4 students, most of them scored around a 16%, the rest of them scored 100. What does that tell you about that math test? Based on what my data is showing, the majority thought it was really hard. Now, reasons for that could be like anything almost. They didn't study, they were absent, or it was just like a crazy hard test, or this one kid is just like a genius. I don't know. But like that'll tell you, okay, so if all of this is following a pattern and my residuals are close to the x-axis, my line of best fit is close to all my data, then this is a good linear model. This, for example, might not be a good linear model because there's like all that big difference in there. So questions on that? Do we know how to plot residuals? All right, and I think we just covered the interpreting them. So again, closer to the x-axis, your residual plot, closer to 0, the better your line of fit is. So now, continue the practice. You may even finish early because you have some time in algebra. With the additional time you might have, make sure all your other stuff is at a score that you like. Like some of you still might want to do some of your math with like resubmissions or some other things from a long time ago to get those grades done. But that's the whole picture. So 80% or higher is the goal. So it gives you the line of fit. Ordinarily, you'd have to put all your data into Desmos and find it or estimate it by hand, but they're giving it to you. And they're saying match the correct residual for each of the coordinate pairs. So where's my actual data? Is this related to another question? Oh, okay, this is my actual data, I'm assuming. Okay, yeah, so that's what that is. On the left side, they're giving you the actual data. And from the trend line, this equation is how you get your estimated data. Residuals have what formula? How do I calculate a residual? Notes for the top. Residual is it's subtracting, but subtracting what? Oh, so this is the formula. Order does matter. It has to be actual minus estimate. So like A always comes first in the alphabet. So it should be coming first in your subtracting. Actual minus your estimate. So this right here is my actual data. X would be the input, Y would be the output. So when you're doing your subtraction, really you're focusing on just the Y's. And then your estimate comes from this line. And your estimate should be for the same input. So what's the input for this first coordinate? What's the X for the first coordinate that's here? There you go, the difference between inputs, outputs. X is always the input. Y is always the output. So what's my X in this first coordinate? 5. So that's what I'm gonna plug into my equation that was given to me. So I can get the estimated Y value. That was my watch calculator. So I have 1.1 times 5 plus 3.4. So my estimated value for that is 8.9. I don't know where to put it, I'll put it right here. Remember, it's actual minus your estimated. So what's 8.8 minus 8.9? Positive or negative? Negative, and it's a smaller number minus a bigger one. So negative 0.1. And that's how you're doing it. So then same thing for this one. You have to plug in your X so that you can get the estimated value. You're plugging it into the line that you're given. And then okay, so you plug it in 1.1 times 2.5 is 2.75 plus 3.4 is 6.15. So that's my estimated value. It needs to go actual, which this is what my actual is, 5.95 minus my estimated. And that's negative 0.2. So that's how you're doing these. Does that make sense? Can I let you guys try the rest now that I showed you 2 other sides? And then we can verify that they're right still before you leave. But just know the process. X is your input, that's what you should plug in for the X. Your estimated Y's from the line. Do we have questions on other parts of the practice, or is it just that? So everyone else get the answers to this. So let's see. Table 3, what did we get for this block right here? Table 1. Table 1, what did we get for this block right here? Or is that and then process of elimination, let's see if that's right, and it is. So hopefully you guys know the process. If not, I can show you at least one more of these. Let's show the one where it's 0. So for this one, what do I have to plug into the equation? 1.5 and plug it in for the X. So then the equation's given to you. Now put that in your calculator. 1.1 times 1.5 plus 3.4. You get 5.05. That's my estimated. So you need to do actual. So here's my actual minus your estimated, because they happen to be the exact same number, is why that is 0. Questions on that one? Questions on any other? Even 3 on this practice. I'll try to put it to where it gives you partial credit on that other one. I don't think it was. So, okay, plots of residuals for 4 different models of the same data set are displayed. Which of the following represents the plot of residuals from a model that fits its data best? So the data is the same, what's different is they use different equations of a line. So like, our computer would always give us the best, but they're not showing us what the raw data is. They're only showing the residual plots, so that's where you need to like pay attention to that. So based on what we learned earlier today, and I know you can only see some at a time, does this one look pretty good? Do you think that that one's going to be the one that fits the data best, if it's like scattered like that? All right, it just depends in relation to the other one, so remember that one. Do you think A or B is better? So I showed you A, here's now B. I'm assuming there's a C and D. So which is better between these two, A or B? B so far, so don't pick A. Now let's see between B and C, so memorize B. Here's C, which is better, here's C. B still, because we want some above and some below. B has too many of them below. And then now compare B to D. So here's B, memorize it. It should be B. Because again, you want to be close to the x-axis, but you still want some above, some below. Question? A great question, I think. All right, anyway.